Welcome to part 3 of the video series on parent functions. In this video, we're going to talk about something called the domain and the range of a function. To give you an example, let's just go ahead and graph one of these. I'm actually not going to graph it from an equation, I'm just going to draw it for you. And I'll start right here. I'm going to do a square root function. Now we already know how to graph these things from an equation, but I'm just going to draw it. Because I don't really want us to think about the equation so much. I'm going to think about this picture, right? If I were to plug in, and I didn't know, let's say I didn't know what this equation was. Now, you could probably figure that out if you know how these things work, and I would expect you to. But let's say you're not given this equation, and I asked you what numbers could you plug in? What x values could you plug in? Well, you don't have an equation to tell you what's allowed and what's not allowed, but if you look at this picture, you can already see what is allowed and what's not allowed. If you plug in 2, that's right here, you get an answer, right? And it is this number up here. If I plug in 2, well, what do I get? I don't have an equation to do it in, but I know that if I plug in this 2, I get the answer 4. Why do I know that? Because this coordinate is 2, 4. So hopefully that's clear. If there's not an equation, you can still find out what the equation would give you, because that's what this graph is. This graph is the picture of all the different inputs and outputs. And we talked about that way back in our first linear functions video, right? So are you allowed to plug 2 in? Yes. Why? Because there's a dot under 2. What about 3? Am I allowed to plug 3 in? Well, yeah, because when you've plugged 3 in, there's a piece of graph there. If that's kind of weird to say, but there's part of the graph is there. And what is that answer? That answer is 5. So I know that if I plug 3 into this mystery equation, I'm going to get 5 out. But the point is, even if I don't have the equation, I know that 3 is part of that I can plug 3 into it. What else can I figure out? Well, can I plug 1 in? Let's plug 1 in. Well, if I do that, what happens? Well, there's no graph where that is, which means there was no answer when I plugged 1 in. So if I plug 1 into this equation, I don't get an answer, do I? It's not going to show up. How do I know that? Well, I know that because there's no part of the graph there. If I plug in 1, there's no answer. All right? So 1 is not allowed to be plugged in. What if I plugged in something way over here, like, say, 10? I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's 10. If I plug in 10, what do I get? Well, I don't know what I get, but I know that I'm going to get something because that arrow, this arrow here, means it's going to go forever. So even though it doesn't reach that point, I know that 10 will give me an answer. What answer will it be? Whatever this is, somewhere around in there, right? It's something up there, and I don't care what it is, but the point is, I'm allowed to plug 10 in. So how would I write down the concept of all the numbers I can plug in? Let's say I wanted to write down a list of every single one of them. Well, I could write down 1 and 2 and 3 and 4 and 5. I could write the list of whole numbers, but what about all the numbers in between? How would I list that? And maybe 10 million and 2 billion and all the big numbers out there, because this goes on forever. How would I write down all the allowed x values? Well, here's what I would do. I'm going to start with the furthest point left. Let me get rid of some of this stuff. I want to make this as simple as possible. I'm going to ask myself, what's the furthest point left this graph goes? Well, it's this point right here. What's the furthest point left? Now, I drew an arrow down, but I'm not thinking about down. I'm asking myself, what's the furthest point left? Well, this is going to be a left and right number, is my point. So this number here is the furthest point left that this goes. What's the furthest point right this graph goes? Well, there isn't a point. It goes on forever and ever and ever. So there's not a furthest point right. So we might just call that infinity. It's not a number, but it serves our purpose, right? So if I want to know the furthest point left, this is it too, and the furthest point, quote unquote, is infinity. How would I write that? Well, if you remember back to how we did interval notation and interval inequalities, you would write that as 2, 8. And we're including 2 because it's closed. This interval is all the x values that this graph covers, and that is called the domain. That's what this is. So if someone asks you for the domain, they're asking you for all of the x values that are allowed to be plugged into this graph. In other words, all the x values under that graph. Another way you can think of it is, what's the furthest point left and the furthest point right? Assuming there are no gaps or holes in it. And that's something else we'll get into maybe in the next unit or something like that, but not right now. All right, let's do another one. Before I introduce the other concept, let's just stick with this for a bit. Let me draw another one. Let's try, like, say, here. Same function. And I want to know the domain. What I'm asking is, what's the furthest point left and the furthest point right of this graph? In other words, what are the allowed x values? Well, this is a 2D picture, right? So this coordinate down here, it has a left and right number, right? And it has an up and down number. But right now, I'm asking you how far left and how far right. So the only thing that matters is that left and right number. It doesn't matter how far down that is. Does that make sense? It doesn't matter where it is up and down. All I care about is how far does it go left and right. In other words, this boundary, which is defined by this number. Why? Because that's what this spot is. That's the furthest point left. I don't care that it's down to. That doesn't matter to me right now. All I care about is how far left does it go and how far right does it go. Well, this is an arrow. It keeps going forever. So the furthest point left is -3, and the furthest point right is infinity. That's how that works. Now, I could draw a different graph. Let's try another one. Now, it does not matter what this graph looks like. You don't know how to write the equation to that, and it does not matter, because all I care about right now is left and right numbers. So if I asked you for the domain of whatever this thing is, I'm asking, what are the allowed values of x? In other words, these numbers down here, which ones of those have an answer up here? Does that make sense? So when I plug them in that way. Now, if I plug in a number over here, there's no answer, right? So that's not going to be part of it. But if I plug something in over here, does it have an answer? Yes, because this keeps going. So I'm asking you for all the x's underneath. Well, what's the furthest point left this thing goes? Well, the furthest point left, not a point again. I don't want to keep saying that. Can I just say infinity? I know it's not a point, but just so I don't have to keep saying it's not a point, but I'm just going to say the furthest point left is negative infinity. It's not technically, but that's where it's going. The furthest location or point right is this point. So if you look at this graph, this is the furthest point right this graph goes. How far right does it go? Now, don't give me 4. A lot of people will say 4. Okay, it's 4 up, but I don't care how high up it is. Let's say someone asks you how many miles away is Walmart. You're not going to say how high it is. You're not going to give them an elevation, right? You say it's 5 miles or 2 miles. You give them the left and right number. You don't care how tall it is. If I ask you where it is left to right, a distance, you're going to give me this number, which is 2. Now, a lot of people, I'm going to write this down, and I'm going to go ahead and tell you this is incorrect. So if you're only half paying attention or you're not being very careful here, what I'm about to write is wrong. But a lot of people will write things like this. And this is incorrect. Which one of these numbers is bigger? Well, the 2 is bigger than negative infinity. And if you remember back to our interval notation video, interval notation needs to look like the picture. In other words, it needs to be in the order with this picture. This is kind of like saying, I've got an appointment somewhere from 5 o'clock to 3 o'clock in the afternoon. That doesn't make sense, does it? Because you gave the later number and then the earlier number. That's not that doesn't make sense. This is like saying from to all the way to a negative number. That's backwards. So if you think of it that way, it should be obvious that the negative number, or the smaller number, in general, has to go first. And that's what the picture shows. Remember, when you use this notation, you're actually just, it's a shortcut for this picture, right? So this is on the left, this is on the right. So this is on the left, this is on the right. That's how you have to draw it. The domain is how far left it goes, then how far right it goes. Now, the domain can get more complicated when the graphs have gaps and holes in them and things like that. But again, we're just doing just the basic concept of the domain right now. Okay, let's do one more, and we're going to use that one to introduce our next concept as well. Let's draw this one. We'll use the square root function again. I like the square root function for this one because it has an endpoint, and that helps us out quite a bit when introducing this. All right. Let's go ahead and write the domain, okay? And you should be able to do this. We've done a couple examples. Try to write the domain already. Go ahead and do that. All right, so the domain is how far left and how far right. The furthest point left, actually, the furthest point left, let's go ahead and draw it, is this point. And again, if I'm looking for left and right numbers, I'm looking for the x number. That's what the domain is the x-axis. So that's going to be this number right here, -1. And it goes all the way to the right forever and ever and ever. That's infinity. So my domain is -1 to infinity. That's my domain. Now, so far I've only talked about the numbers that I'm allowed to plug into this function. In other words, the x numbers. But what if I wanted to know all the numbers that are allowed to come out of this function, all the answers, all the y values? Well, that's what we're going to call the range. Let me go down here and go ahead and write that word. The range is going to be all the y values, all y values. If the domain is all the x values, the range is all the y values, and that's all the answers. So ask yourself this. Is 2 an answer to this function? In other words, can y equal 2? Well, where is y equals 2? It's right here. If I were to ask myself, does this graph ever touch anything along y equals 2? Well, no, it doesn't. It stops, and then this part keeps going up and up. So 2 is not an answer to this equation, whatever it is, whatever function this is, I plug it in. I'm never, ever going to get a 2. Why? Because this is 2, and this graph never touches it. So that's not part of my range. My range is all the allowed answers. Now, what if I said, is 5 an answer? Well, let's find out. Well, where is 5? Well, 5 is up here. 1, 2, 3, 4, 5. 5 is up here. Well, look, that's an answer. If I plug in 0, I get 5. I know that because that's a point there. So 5 is going to be in the answer of my function. That means it's in the range. What about 100? Well, even though this is kind of leveling off, it's still going to keep going up and up and up. Very, very slightly and very, very slowly, but it's always going up. So you can think of it that eventually it will always go up. So any number I pick higher than this green line is always going to be in my answer. Okay, let me put all this together. So the range is going to be all the numbers that are the answers. In other words, all of the y values. So what is the smallest y value? Well, it's going to happen at the lowest point of the graph. Where's the lowest point of the graph? Right here. Let me do a better job of erasing this stuff. The smallest y value is where this red dot is. That's the lowest this equation goes. Okay? What is the lowest value? Well, that's the number 4. Because when I'm dealing with range, when I'm dealing with answers, I'm dealing with y's. So don't give me an x number, give me a y number, because this is a y value. And I'm asking for the lowest y value. And what is the lowest y value? It's 4. So let me write 4. And if I asked how high does this thing go, what is the most or what is the highest y value? Well, this thing doesn't stop going up. So it's going to go all the way up to infinity. And so that's my range. So with the domain, I'm looking at an x number, a left and right number. With the range, I'm looking at a y value, or an up and down number. Right? Okay. Let's try another one. Again, we're going to use the absolute value, not the absolute value. The absolute value helps a lot in understanding this because, again, I've already said this, because it has a point. Let's do this one. Well, I'm not even going to write the equation. Let's just draw it. Let's do this. All right. Now, notice I didn't draw any other points. It doesn't matter because the point is it goes from this spot and goes up into the right. All right. Now, I highly suggest that you pause the video and try this on your own. And then come back and let's see if you got it right. All right. Range time. Range is the x values. You have to give me x values, which means well, if I look at this starting point, the furthest point left, it has a coordinate, doesn't it? It has the coordinate -5, 2. That's its location. If I want to know how far left this graph goes, I'm looking for an x value, which is the -5. Don't say 2. 2 has nothing to do with how far left and right it is. That's an up and down number, so I don't want it right now. What I want is that furthest point left, which is -5. How far does it go to the right? It goes to infinity because that arrow means it doesn't stop. So you're going to write it in that order, and you have -5 to infinity and beyond. Sorry, I couldn't help myself. Okay, let's do the range. Now, if you haven't tried the range yet and you stayed to do the domain, try the range real quick and then see if you get it right. All right, range time. Range, I'm asking how far down and how far up is the thing. In other words, the answers. What is the smallest y value I'm allowed? Or what's the smallest y value I'm going to obtain if I were to plug something into this? Well, it's going to be 2. Right? And that's what that is right there. It's that smallest y value. So that's where I start. And the highest y value, well, remember, as I said before, this arrow, even though it's mostly going to the right, it's still kind of going up a little bit. So it's going to keep going up and up and up and up forever and ever and ever, very slowly, but steadily. And so I get that as well. Okay. Hopefully you did well on that. Let's try this one. What if you had something that looked like an absolute value, but it wasn't? It's not, well, it is an absolute value. No, I keep saying absolute value. I mean, what I'm talking about is a square root function. Let's do something like this one. Let's do that. That'd be fun. We're not going to write the equation of that. It doesn't matter. Again, we just care about the picture. See if you can do the domain and range of this one. This one's going to be a little different. It's going to test your abilities. Domain and range. Go ahead and pause this and give this a shot. Okay, the domain. The furthest, this is the x value. So the furthest point left and the furthest point right. This one's a little different because the furthest point left isn't a point, is it? This arrow keeps going left and left and left. So on the x-axis, this graph keeps going forever to the left. Now, is it going down? Yes. Does it matter? No. All I care about is it's going left. What's the furthest point right this goes? Well, the furthest point right on the graph is this point. And what is the x value of this? That's going to be -1. Does it go high? Sorry, that was a dumb thing to say. Does it go high? Does it go to a height of 4? Yes, it does. Does it matter in the domain? No, it does not. All I care about is the x value. So domain is going to be -infinity to -1 included. Just to remind ourselves, a quick note: all of these numbers, because they're filled in, I don't have any open circles. That's why these have brackets. And remember, you never put a bracket on infinity because you can't include infinity. It's not a number; it's a concept. So infinity will always have an open bracket, well, in parentheses, because it's something that's not attainable. It's not a number. Okay, uh, let's do the range. Let me get rid of some of this mess if I can. There we go. Now we're only dealing with up and down numbers. What is the furthest point down this graph goes? Well, this arrow has a kind of a downward direction it's going, so you can imagine it going to keep going down and down and down and down. So what's the furthest point down this thing goes? Well, it's not going to stop. It's just going to keep going, so we're going to call that negative infinity. What is the furthest point up it goes? Well, it doesn't go any higher than this 4. Nothing above this spot right here. It doesn't keep going. So the furthest point up is 4. So that's my range. Now, which one goes first? Remember, we always put the smaller number first when we're doing these things. So the smallest number or concept is negative infinity. The largest number here is 4. I cannot stress enough how important it is to put them in order. This does not make sense. You can't do this. You have to put them in order. It's like saying from 4 to negative infinity. Does not make sense. You have to start with a smaller number. I'm actually going to write that out. So if you're taking notes, you can actually write this down. This has to be smaller, and this has to be larger compared to each other. The left one is smaller, the right one is larger. Okay, that's how that works. Let's do something else. Let's do a quadratic. Now with this, I didn't have to draw the dots, I guess, but it does make the picture look a little prettier. Now, if you're feeling confident, which I hope you are, please feel free to pause this video and give this a try. Try to figure out what the domain and the range are of this quadratic equation. All right, let's actually do this one backwards. I'm gonna actually talk about the range first. How far down does this graph go? In other words, what's the lowest point of this graph? The lowest point of this graph is this point right here. And if we're dealing with the range, we're looking at how far down or up, either way you want to think about it. It's a vertical number. It's an up and down number, a y number. So the furthest point down is this number 3. And the furthest point up, well, it's not a point. It goes on forever and ever and ever and ever upward. This one's very obviously going up forever. So the up and down numbers are 3 and infinity. Which one's smaller? Obviously, 3 is smaller than infinity, so that goes that way. So that's the range. The range with this one is not too complicated, I don't think. It should be fairly obvious to see how low and how high it goes. The domain is a little bit more interesting, I guess. It's not once you understand how it works, but I have found in class when I introduce domain and range using things like the square root function, they're used to always seeing a number. But if you think about how far left this graph goes, this is an arrow. So even though, yes, it's going up forever, it's also going left forever. This is always going to the left. Slowly, but it is. And this is always going to the right. So this graph goes forever to the right and forever to the left. There is not a single x value down here. There's no spot on this line that doesn't end up under that curve somewhere. Every single number in existence, all the way left and all the way right, will be underneath this graph. In other words, you could plug in any number and it will always give you an answer. It might be way up there, it might be really big, but it'll eventually be there. So my furthest point left is negative infinity, and my furthest point right is positive infinity. You can do that. You can have both of them. That just means every number, every real number is allowed to be plugged in. Okay? That's what that looks like. Okay, let's try one more. Tell you what, let's do this. Let's do the multiple things here. I'm going to actually graph this. And as a bonus, why don't you see if you can write the equation for this thing? So this is a quadratic. Oops, I gave it away. Well, you should already know it's a quadratic. But see if you can write the equation for this. And then once you write the equation, see if you can write the domain and range. Do that. All right, so to write the equation, first of all, we recognize that it's a quadratic, so it's going to be something squared. And we know the vertex is at -2 and positive 2, 3, 4, 5. So if you think back to all the examples of when we were graphing these in the last video, it was always something squared and then a number on the inside and the number on the outside. The number on the inside was the reverse or the opposite of the x value, and then the one on the outside was exactly the y value as it was seen. Because that way, if you think about it, if you swap it, you get that, right? So that's how that works. But also, we learned that if there was a negative out front, it flipped it upside down. And this picture is upside down. So that is what that equation looks like. So that's just kind of a bonus to see if you can go from a picture to an equation that way. It's really not difficult if you know how to graph them. Okay, domain. How far left does this thing go? Well, without dragging this out anymore, because we've done this quite a bit, it goes forever to the left and forever to the right. So the domain is negative infinity to positive infinity. In fact, all parabolas, unless they're modified in some way, in some special case, will always go from like negative infinity to positive infinity, always. The range, how far down and up does it go? Well, this thing keeps going down forever and ever and ever. So the furthest point down is negative infinity. And the furthest point up is this point right here. And the furthest point up is the number 5. Remember, when we're dealing with range, we're using y values, y numbers, and that's the y value of the vertex. So I'm going from negative infinity all the way up to 5. Okay. The concept of domain and range is can be deeper than this. That you can obviously make more interesting pictures with holes and gaps, and you can do step functions and discrete functions, all kinds of interesting things. But this should serve as a good introduction to the concept of the domain and range as being left and right values and up and down values. And that's really the extent of it if you're dealing with parent functions and translations of them, all the different variations you can see of parent functions. So I think that's where we're going to leave this this time. And in the next video, we're going to talk about how to analyze where a graph is going up and where it's going down. In other words, where it's increasing in value and where it's decreasing in value. Shouldn't be too difficult. It's the same kind of deal as this. But again, we're going to save that for the next video. Thanks again for making it all the way to the end, and I hope you learned something. I hope that you followed along, and I'll see you guys in the next video.